Morning, guys. Here's just an overview of yesterday's homework, or what was due yesterday. Gonna post the pictures so you can take a look, and today's gonna kind of be a day just to kind of reflect on what we have covered, submit what we haven't submitted, and then I'll have one more problem for you guys to try. So at the top it says PDF and text because the PDF version and the textbook had the same identical problems, just different numbers. So the 6 and the 2 was for the PDF and the text. So the first one was flipping a coin, heads or tails, and then rolling a die, 1 through 6. So there are 12 different outcomes. Now B was saying that you wanted heads and a number greater than 4. So 5 and 6 are the only two numbers greater than 4, so heads and 5 and heads and 6 were the only two outcomes. Since there were 12 total outcomes, and we were looking for 2 of them, that's 2 out of 12, or 1/6, or about 16.7%. The next one was talking about wire options. So we had 4 wire options. Then once we plug one into a spot, we only have 3, then 2, then 1. So 4 times 3 times 2 times 1, or 4 factorial, would be 24 different outcomes. The next problem was almost identical, just different things instead of wires. They were cities. And so once again, instead of colors, it's cities, so 4 times 3 times 2 times 1, or 24 different ways that you could visit those cities. Next up, again, same logic, but now you had 4 fertilizers, 3 temperature zones, and 3 water treatments. So 4 times 3 times 3 was 36 different combinations. Number 22, we had 10 finalists and 3 were being selected. The order mattered due to the payout. You had more money for the first selected, less money for the second, even less than the third. So that's what makes it a permutation. So out of 10, we're picking 3. Right here, I'm going to go ahead and cancel out the 7 factorial in the numerator and the denominator. So I'm just left with 10 times 9 times 8, or 720. Next up, we had 10 software packages. We want to pick 3, but they're just free packages. There's no order that you get a free software package if you get selected, and the next person gets the same free package. So that's a combination, because as long as you're selected, that's all we're looking for. And so 10 factorial over n minus r, so 10 minus 3 factorial, which is 7 factorial, times r factorial, which is 3 factorial. Over here, I'm going to cancel out these 7 factorials, so I'm left with 10 times 9 times 8 equals 3 times 2 times 1. Now the 3 can cancel out with the 9, the 2 with the 8, so there's my reduction. So I get 10 times 3 times 4, or 120 different ways to pick 3, given that we have 10 to choose from. Next one, we had 12, and we were picking 5, because we had 5 problems that were going to be randomly selected out of the 12 that we should have done. And so the math is there, 12 factorial over 7 factorial times 5 factorial. Again, canceled out the 7 factorial, so I just had 5 factorial over the first half of the 12 factorial. And then I went ahead and reduced. 5 goes into 10, 4 goes into 8, 3 goes into 9, 2 goes into 2. So I had 12 times 11 times 2 times 3 times 1, or 792. Now, if you only completed 5 problems, that means you only have one combination of 5 problems. So that's 1 out of the 792 possible that could be selected. So there's about a 0.1% chance that if you submit your 5 problems that you'll get a 100%. Now, Sylvia only did 7. Now, of the different combinations of 5, when we do the math out, 5 factorial cancels out. I simplified the 2 and the 6 to get 7 times 3. There are 21 total combinations. So of the 21 combinations that Sylvia could achieve, out of the 792 potential, there's a 0.027 or 2.7% chance that if she were to hand in her homework, that the 5 that gets selected would be selected. Now the last one was tricky. We are only picking 6 people, but we are choosing from 12 different candidates. 7 of those candidates are women and 5 are men. There's no seniority, order doesn't matter, so therefore this is a combination. The 12 will be our n value, the 6 is our r value. So we're picking 12, or we're picking 6 of the 12. So if I were to do the combination of picking 6 of 12, I would have there's 924 different combinations. The math is right here. 12 factorial over n minus r factorial times r factorial. So that would be 12 factorial over 12 minus 6 factorial times 6 factorial. I went ahead and I canceled out the 6 factorial. And then here I just went ahead and reduced the 6 with the 12, the 5 with the 10, etc. I get this, which is 924. Now the next part was saying, what if I just want to pick all women? So that means that there's only 7 women to choose from, but I still need to pick 6. So then that will be the 7 factorial over 7 minus 6 factorial times 6 factorial. So the 6 factorials cancel out, and I'm just left with 7 over 1, which is 7. Now the last part is, what is the probability? Oops, sorry about this, guys. What is the probability of picking all women? Well, given that there's 924 different ways to select 6 people from 12, there's only 7 ways that you can select 6 people from the 7 women. So therefore, there's a 1 in 132 chance, or an 0.8% chance, that if you randomly pick from 12 people, that they will all be women. I hope this helps. I'm going to post this, and I'll post the answers, and we'll post today's assignment. Good luck, guys.